I guess, a little bit of an unusual client, and we're a city, and so a little smaller than the DOT scale that all of y'all are used to. So some of what we face is a little different, and we find that very frequently that research and things, products and things that are built for the highway environment are usually excellent products, but they don't always serve our needs exactly right out of the box, and we just have to maybe do a little customization and figure out what works for us. So this is kind of one of those things where we tweaked it a bit and found a pretty good solution. So do I just hit the arrow keys? Is that the easiest? Yeah, okay. No, not that. Sorry, there we go. All right. Get my right and left. Okay, so why smart grouping? Just is kind of the, we'll touch on that a little bit. Give you a background of the Austin Street Network so that you understand kind of what our pavement system looks like. For some of you, it'll be different. For some of you that manage secondary roadways, it's going to be very familiar. We're going to talk about typical street maintenance service plans for the city, and that also helps you kind of understand why we want to do the smart grouping. A little bit about our pavement management analysis that implements this process, and then talking about how we really get into that smart grouping, and then just a few examples. So we want to combine a large number of separate project candidates into more practical urban projects is kind of the bulk of what it is, because we have almost 27,000 individual street segments, and so all of those we manage our network at that granular level of each block to block, intersection to intersection segments. And for us, that makes a lot of sense because we go along, we can stay in sync with our GIS that way. We're not using a linear referencing system. And so it works okay, but it's a bit complicated to have all of those segments and to have all of those individual candidates come up for us. So it can be difficult to get also in the urban environment, consistent and repeatable data. There's a lot of issues with data collection that make it a little challenging in the urban environment. We'll talk about some of that. We want to kind of tease out also some of those clustering of the data, which leads us to build fairly tight decision trees, and that has the effect of kind of teasing out different treatments, but in doing so, we end up with a smattering of different treatments picked out for areas that maybe should have the same treatment for practical reasons, so that we do the right treatment on the right roadway at the right time. So with all of that in play, there are our major motivations for doing this concept. So to talk about Austin Street Network a little, just to give you a picture, here's the 30,000 foot view, which you can't see very well, but we'll zoom in some so that you can get a little idea. So here's some an example of some of the crazy network geometry you get with modern subdivisions. Lots of cul-de-sacs, dense packed roadways, lots of little short segments. So it's obviously a very different network than a highway network or a county primary farm to market kind of system. So that's what a lot of our roadways look like, and we have to figure out how to make sense of pavement management results that we get from that. Here's the ages of the subdivisions. Not surprisingly, the core of Austin is the old sections of Austin that was built first, and then the outlying areas as urban sprawl hit us are all the newer subdivisions. So consequently, our best guess on the ages of some streets and our best records on as many of the subdivisions as we had, we were able to pin down fairly good ages on most of the streets from probably the 50s on, and anything before that is just a best guess. But again, no big surprise, the older parts of Austin are in the core, and as you get further out, we've got newer subdivisions and newer streets. And you'll see obviously a correlation to the scores that we have as well. So we have Swelling soils, expansive soils on the east side of Austin. Many of you are maybe familiar up through the whole center of the United States. There's a swath of expansive soils running up through Colorado and then all the way up through the Dakotas, I believe, and it's a challenge. So some of our streets are on really good soils, and then some of our streets are on really bad soils. And you know, if you put anything like a pavement on a bad foundation, it doesn't perform very well unless you do all the right things. And over the years, we unfortunately found that many of the older subdivisions were not stabilized very well, and they didn't do anything special for those soils. So those pavements don't necessarily perform very well. So we have to accommodate that in our decision-making process and also in moving forward, setting our standards for streets. So to talk a little bit about urban pavement data collection, this has been a challenge for us. Our citizens care about the smoothness of the streets. So we've used the IRI and settled on that roughness measurement as being our primary driver. And that's really, it makes sense and it's really good. But gathering IRIs in urban streets is a little bit challenging. It really was designed for the highway environment by its initial definition. And of course, you know, everybody's doing the best they can to collect good data, but we have a number of problems. And this is a shopping list of those problems. It can be, obviously, the short streets with start and stop is a problem. You can't maintain speed with the van. And the data collection for IRI is affected by speed, and especially when you're at those low speeds and not being able to maintain any kind of good, consistent data collection rate. There's lots of speed changes. The shape of the street with drainage and everything that you might encounter in the urban environment changes much more suddenly than it would, of course, on a highway environment when you're driving down the lane. So we run into all these kinds of different things that will affect the IRIs. So that's been a real challenge for us to see the scores bouncing around. They are very representative of our network, but they're not super consistent from segment to segment, year to year. Tracking of that data from finding trends on any single street is very, very difficult. The scores just bounce around too much to do that. So again, it's a good network indicator, and it may be a good neighborhood indicator, but it's really difficult to get super reliable scores. There is a study going on right now, which we were very pleased to hear about, and should be coming up with results soon. And we're very interested to see what that says. They studied that low speed, smaller street environment of the urban setting to look at how collecting roughness scores might be improved and what might be some of the factors that are affecting it most drastically. So we've got some things that we could do, including following that study's recommendations, but we might change our data collection methodology. Right now, we just collect one lane, one direction on every street if it's less than 48 feet wide, and then on those wider streets that are likely to be 5 lanes or more, we collect one lane in each direction. So we definitely don't have a 100% survey of every lane. We also don't track which lane they drive. They tell us that each time, but we don't make sure, we haven't been making sure from year to year, collection cycle to collection cycle, that the vendor collects in the same lane as they did before. Again, that creates scatter, but it's a big undertaking to do that kind of tracking for us in the urban environment. So we do collect half of the network each year. And so we do have pretty current scores on all of our streets. It's just, it's already a lot of data and a fair amount of expense for us at the local level. If we were to bump that up and collect more data and do more tracking on it, obviously there's a cost there. We may find that we have to do that to get reliable scores, but that's something that we're really going to be looking at as we move forward and trying to figure out what we can do to get better roughness scores. So we're going to look at this area come back to this a few times. It's just a small area bounded by I-35, Cameron-Dessaw, Yeager-Palmer, and Breaker Lane. It's this kind of odd-shaped area here in the northeast of Austin. And so we're going to use this as kind of a discussion area, see what was picked out by the pavement management system and what we did to adjust those. So here's the scores. I told you that there was pretty good correspondence between the old Austin and the scores. And you can see downtown and old West Austin and old North Austin are still showing to be streets that are a bit rough. We use, for public reporting, we use a 5-point scale that's basically like your old report card on the letter grades, A, B, C, D, and F. Try to, that's mostly comprised of that roughness score. So zooming in a little bit, you could see a little more detail here, and then here's a closer in view of a subdivision. You can see it's kind of mixed. It's the very few places that are extremely uniform, so that obviously is a challenge. So going up to our area that we were talking about, these are the scores in that area. There's a couple of streets in really, really good shape. There's a number of them in fair and good condition, and a few in pretty bad shape. So this really isn't a bad area, but it is still somewhat mixed and a challenge to pick out what's the right thing to do that will make sense over most of that area. So here's the segment IRIs, and we grade the arterials more harshly than the collector streets and relax even more on the residential streets. Most of these are residential with a few collectors sprinkled in there, so they're mostly following this. But our IRIs are probably quite a bit higher than your highway desired IRIs, but in the urban setting, these numbers are not that outrageous. Most of them are in the 100 to 200 and 300. That's kind of the bulk of what we see, with just some of our worst streets sticking out into the 400 and 500 IRI range. Now, but a lot of that is maybe a bit artificial. There's castings in the street so that every manhole they hit, every valley gutter they go through affects those scores. So we kind of take the IRI with a little grain of salt and try to just use it as a relative indicator and not say that street necessarily is that awful as it might seem to somebody who's an IRI and a profiling expert. Here's the network. It's kind of clustered. You can see there's a whole lot of the network that's in a pretty tight band. That's why I was talking about trying to have decision trees and processes that tease apart the network a bit. And in doing that, you end up with selections that might kind of scatter a bit more than just letting everything come out to be the same choice because everything's all clustered in the same place. The similar thing for the PCIs. You can see most of the PCIs are kind of hovering around the similar values. For us, it's in the high 90s for the PCI because we only do 4 cracking distresses in our PCI. So there aren't as many deductions as there are for some people who are doing a more full-blown, like we heard earlier, 10 or 12 distresses and subtracting that from the perfect 100 score. So for us, a lot of our scores are clustered near the high end. So our street maintenance plans, we do a lot of preventative maintenance, the thin surface treatments, seal coat, slurry seal, and fog seals, tire rubber modified surface seal. We're trying to do more crack sealing as preventative, even though that's not a full surface treatment. And then we try to do a lot of overlays as we can afford them because that's what really takes for us to improve roughness scores. either overlay, rehab, or reconstruction is all that's going to really make a street a whole lot smoother. The thin surface treatments, of course, preserve the value you still have in those streets, and we think that's incredibly important. But if we want to make things better and make people even happier with the streets to raise that citizen satisfaction level, we need to concentrate on continuing to do a lot of overlays. But you can see we do in the outlying areas, we do a whole lot of surface seals. The lighter green is just older treatments, and the bright green is the most recent year. So you can see we try to get around to the entire city in about a 10-year period to do something to every street on average. There's nothing magical about that other than it's kind of an affordable time frame. A lot of treatments can kind of hang on for that 10-year time window, some a bit shorter, but we can mostly have active surface treatments on the entire network if we can keep up with a cycle similar to this. We'd like to be even a little bit more aggressive, but this is where we're at right now. So looking at the whole city, this was the 2017 plan. Zooming in a little bit so you can see more detail. This is kind of the central area. This is looking at just an area in the southwest, I believe, but you can see we're picking out larger subdivision areas for those surface treatments with just a few scattered overlays embedded in them. So that's very typical of our program. And this is an area that ended up needing a lot of overlays, but not very many surface seals. But that's an older area of town near the river, so that's that central and old West Austin that needs a whole lot of overlays to improve the roughness scores. So when we get to doing the pavement analysis, our decision trees are pretty detailed for the urban network. This is the residential decision tree, and this is this middle section of that. We use the PCI scores. We even use the time since the last surface treatment and last time since the last major treatment, which is the heavier class items, to help us space out those things so that we're not revisiting the same streets over and over again, because we do have an aged network that has quite a few streets in rough condition, and we can't afford to keep going back to the same streets over and over again when we're kind of in a preservation mode for even some of them. We have to extend their life as long as we possibly can. We may hit them for some major treatment at some point in time, but we can't afford to come back very soon and have that picked out again too soon for treatment. So we do a typical analysis with the optimization, trying to find, okay, what's the smartest way for us to spend the money on a segment by segment basis, just like everyone else is doing. And this is what we came out with. It's pretty mixed, like we would expect. The scores were kind of mixed, and like I said, we have pretty detailed decision trees that are trying to slice that thin on the decision. So we ended up with a menagerie of choices here, and also a variety of years too, which is difficult to accommodate in any practical way of doing this kind of treatment. So that's what we get from just running the analysis by itself. But what we also recognized is we could use smart grouping of those, because a lot of those are fairly similar choices. It still was only a 4-year window we were looking at. And does it really matter too much if we slide a surface treatment up or back a year so that we bring them together? And we've thought that from a practical standpoint of putting out projects and being consistent in our treatment of the network was worth that detuning, that perfect optimization. The optimization got us in the ballpark of saying this is what's probably right mathematically, but we detune it just a little bit to make it more practical for us to accomplish. And so, like I said, it's inefficient to skip around. Excessive skipping around perpetuates inconsistency and makes future choices just as difficult as the first time you went through it. So segments that you leave out are treated differently and kind of are put on a different path maybe for your maintenance profile. So we want to make those things as straightforward as we can. And also our public, gets confused about, well, why'd you do that and not this? And they look like they were about the same to the citizen. So we want to give a pretty uniform product to the citizens when it makes sense to do so. So we prefer larger contiguous neighborhood groupings when it makes sense. So to do that, we created these larger areas we called supersections, because each segment we used to call them sections. So each segment of the network was, just potentially just picked out by itself. But we created these neighborhood groupings that could be then treated as a larger group, so that we could go back and look at the project selections, the candidates, through that lens. We leave the major treatments alone for the most part, unless we decide to modify them by hand and kind of maybe do a little massaging of that, but that's by choice on our part. The software, the way we configured it, we said, hey, if it picked an overlay, that's what it needs. And if it picked an overlay next year on this one, and an overlay 2 years from now on this other one, and 3 years from now on this other one, leave it alone. So for right now, we're focusing on the thin surface treatments, adjusting those, making sure that they made sense as a large project. And then the same thing with those surface treatments, adjusting the years, because we felt like those were fairly equal choices. So here are the supersections at the city level. Zooming in, this is the kind of north half of the city in the old center. Just another neighborhood area zoomed in, and then back to our little area here. You can see in this area that I had picked out to look at, there's really basically two groupings, plus the arterials. We separated those so that arterials stand alone as their own supersection, but everything else, residential and collector streets, all were grouped into these bigger neighborhood groups. Most of them have similar ages, pavement structures, materials, traffic patterns, and maintenance history. So they make a lot of sense to group in that perspective. And again, it's the way things had been done by hand. And so there was a reason for that. It wasn't by mistake that kind of choice was made in the past. And we felt like we could kind of emulate that a bit with a few tweaks to the choices for the system. So after the smart grouping, we run the analysis, and there's an analysis that's built in that Keivan helped build that looks at those groups of projects, supersection by supersection, and says everything in that group, what could I do to kind of homogenize that choice and make sense of it based on what we were looking at earlier. So there's a hierarchy of treatments. Some treatments are more robust than others. Like we feel seal coat is much more robust than slurry seal, which is much more robust than a fog seal. So if a few of the streets in the area needed one of those heavier treatments in that grouping of the thin surface treatments, we'll elevate everything to that level, saying, well, there's probably a good chance that everything in that area probably needs a seal coat. Or if a slurry was enough, but there were a few fog seals in, we'd elevate those fog seals to a slurry and say, okay, the whole area can probably be done by a slurry seal, and that makes sense. So here's just a few examples of ones. This area came out as a beautiful crack seal area, but the years were kind of mixed. So obviously, easy fix for us. We do them all in the same year. So they made perfect sense as a choice. They was the right choice, but the years were going to be kind of messy. And to send a team out there or a contractor out there just to do a few of them this year and a few of them next year and a few of them the year after that doesn't make any sense. So this was an easy fix, and it just makes perfect sense to execute it this way. Here's another example where the area got picked out for mostly seal coat and one of the various types of seal coat. We have 2 different size rocks of seal coat and then level up in seal coat that we allow to be choices in our treatment selected. So all of these are one of those types. There's a bunch of crack seals and there's some overlays as well. And then here's how I would optimize that. Leave the overlays alone for those major sections that probably needed more than just a seal coat could handle, but bring the rest of the area to one of the seal coat choices. And I didn't show which one it is, but they probably all got elevated to a seal coat 6, which is a small rock seal coat that we use in our subdivision areas. People seem to tolerate that pretty well. Seal coat's tough in the urban environment. A lot of citizens don't like it. They call in and complain about, why did we put that gravel road out there? But it's an excellent treatment, and we've continued to try to do it well here by sweeping enough, rolling enough, and using the smaller rocks so nobody can claim that we're breaking their windshields when rocks kick up or anything. So we've maintained just enough acceptance to keep seal coat around here as a good urban program. And so that's probably what that was. I don't recall if it was 5 or 6. And so the years were also inconsistent. So looking at that, brought them almost everything to 2020, except for the arterial, which left in 2021. And just one more example. So this was a mix of overlays in this area and some seal coat. The overlays it's probably a pretty old area and just needed those. The years, left the years alone for the overlays, but brought all the seal coats to the 2020. And so that's the thing in a nutshell. So far it's worked pretty well for us. We have to do some hand cleaning up afterwards. The supersection process catches most of what we want to do, but there's still some editing to do after that. So Vina has been working on how we can maybe tune our decision trees a little differently. We may even someday use the supersections as a way to pick out the areas just from the get-go. But for right now, we want to know what the individual choices were, what was the optimal choice based on the optimization analysis. And so that first run of the initial results at least tells us this is what the system would have picked out if it just had its freedom to do anything it wanted to do. And so we can kind of evaluate how much are we changing it by the process that we've gone through. So that's it. Any questions about what we've done? Yes, sir. I guess you want the microphone?
Yep, so very good. So I have a question. Because you change the optimum work plan, but in essence, you group things. So you're also somehow lowering your unit cost, most likely, right? If you group and you send a contractor in that area,
yeah, it's efficient for
right, it's more
either
efficient,
in-house
right?
or contracted.
So you're
work.
reducing your unit cost for these groups of projects.
We didn't explicitly model any cost difference, but we know there would be.
You know there would be.
There would be a difference for us to do things at piecemeal.
Right.
Yes.
So, I mean, and so basically the question, do you take that modified work plan, put it back into the software, and assess the influence on your network?
Well, the supersection routine is built in, so the first run at getting it as uniform as possible is already part of the system. We added kind of an extra, at least one step from what other folks have, maybe 2, because we took the individual candidates, and instead of just taking those candidates as is, because for our candidates are just a block long, you may have a whole different setup with linear referencing and large routes. We just have all those individual pieces. So we could have just promoted those to be the final work product, but what we did is we grouped them with the supersectioning to try to harmonize the choices. Then we also turn those into projects, what we call a project, based on contiguous streets. So if a street had 5 blocks in it that all needed seal coat, in the end, our work plan says it's one project from this street to this street with seal coat on the whole thing because the street name was the same. And so for us, it's a little bit of a different process of building a project and accepting it than probably most of the other configurations.
I mean, one of our clients in the UK is dealing with the highway around London, and they split it into 100-meter sections, and it's by
Wow.
lane. That's their network.
Yeah, that's
So even
granular.
if it's a small network, it's about 33,000 objects.
Yeah.
And they have the same problem, exactly the same
that's
problem as you
granular.
have. So, and they are trying to group things so that they can reduce,
Yeah.
I mean, the group effect, basically.
Yeah, there's a number of ways to do this. We like we said, we tried to do as much automated as we can. So the first supersection run is part of the software where it is making modifications in the master work plan, a database, a separate database of the master work plan. It's making changes to that, moving the years up or back one, changing the treatments, and then we note, was it the original selection by the master work plan? Was it an overlay that was just an override, or was it a supersection modified section? And then we can tell all the ones that have SS were changed by that intermediary run that's part of our system. Then after that, we have to do a little hand tweaking for the ones that just fell through and it didn't get caught quite right, but it's working pretty well. We're going to tweak it some, but it's working pretty well.
Very good. Thank you.
Yeah.
Can you describe that? Is it a right-click function in the master work plan window, that like a routine that you're running to populate those neighborhoods after the initial scenario?
They're
initial
system
optimization?
jobs with a menu choice that kicks it
Okay.
off.
Yeah, it's a system job, so the way it works, it finds the adjacent supersections first, and then based on the specific rules provided, it looks at a 3-4 years window. So it first finds the dominant year within those work plan, and then once that is fine, some treatments are excluded and some treatments are changed into one group. So basically, it adjusts the year and some of the treatments in order to get into modified plan. But it's a system job that comes after the analysis, and it gets all those work plans that we have from analysis in some other window, so it's like adjusted work plans.
Any other questions for Ed or Eva?
Are you synthesizing new street names for these supersections and then running, so just?
No, it's just a number, and each of the segments has that supersection that it belongs to hard-coded in it. It's just another field, the supersection field. So they are just aggregated by that routine, by that supersection ID. You could create names for them, because you could think of it as kind of a routing thing in a weird sort of way. It's creating that group under a name. In this case, we just numbered them. So they could have, it could be a subdivision name, it could be anything you want to call it. Yeah, as long as it's a uniform, unique identifier, you could make supersections anything you wanted.
And then did you run the supersections back through optimization again, or was it
No.
just, it was all?
No, the initial run to pick out the initial candidates is the optimized, and then we admit we're detuning the optimized run a bit. But we feel like we've already got a fair benefit out of the optimization, because it was running the whole network and telling us for 3 years, 4 years, 5 years, whatever analysis we're running, it's telling us that's what we should do. So we think we're launching from an optimized place and just detuning it just enough to make it efficient from a physical, practical perspective, but we hope we're not totally, kicking it out into left field, but we don't do a second optimization.
So most of those treatments are kind of like for thin treatments, preventive, and they're kind of close to each other. So the money that is changed by changing the treatment is actually saved when the crew goes in the field, instead of going 4 years for small segments, and they can go once and do one thing done. That's even more saving the money.
That's a really good point. You'd have to be much more careful about this if you were using all treatments of, rehabs and reconstruction and other things were all thrown in there. These are all just thin surface treatments that are in the mix for this adjustment. And so we don't feel like we're throwing the baby out with the bathwater in that case. Yeah. But you'd want to be really careful if you were going to take this concept and go bigger with it. You're absolutely right. You'd probably want to figure out some way to optimize it again. Yeah.
Ladies first.
Have you had any feedback from the public as far as the impact of the reduction in disturbance of the traffic patterns and things like that? Any way to measure the quality
No.
of life issue?
I appreciate what you're asking, and I wish it didn't feel like it was always the same fight over and over again. But no, when the citizens are unhappy, they're unhappy. It's hard to show big trends for our public for them to appreciate. I agree with you that it seems like over time there should be some benefit from doing things like this and get in, because we try to get in, get out, stay out. I mean, like everyone's trying to do. So this is helping us do that, but it doesn't seem to be a lot of recognition of that. But we're going to just keep after it. Fortunately, I guess on the plus side is our surface seals programs have been quite good. The folks executing them are doing a good job. And maybe because we're doing uniform areas with the same treatment, everybody feels like they're getting the same level of care. That probably is keeping the number of complaints down, just in its own strange sort of way of just treating people equally. But we really feel like we're making the right choices from a pavement management perspective. So as long as the complaints don't go off the charts, maybe we're being more successful than it feels like. But yeah, lots of folks like to call in and complain about things. So we haven't seen any huge reduction. Vina, have you noticed any change in the number of complaints? They seem to come in waves, and it doesn't seem like anything we do has a huge impact on that. I wish it did. I really wish it did.
Our office is on a DK.
Yeah.
Yeah, what's the timetable for smoothing the pavement between Roland Wood and? That's a text dot.
That's what we like. Yeah. Go talk to TechStop. No, we got enough of them that are ours. That's for sure. Was there another question? Yes.
Yeah, great presentation. So change gears a little bit here. You mentioned 4, I think, cracking distresses that you were using.
Yeah.
And you obviously have an auto data collection vendor for your IRI. Is that cracking, those cracking distresses collected automatically? I mean,
Yes.
by the
It's
collection
automated. They they line scan and assemble that, and then use computer recognition for the cracks. It's alligator, block cracking, transverse, and longitude. And they had a little problem with block cracking because I guess block cracking is a little hard to recognize by a computer. So that might be the one that's a little iffy, but that's okay because alligator cracking is probably one of the more severe for us to worry about even on the urban network. So I think we're getting pretty good information. It's at least very consistent.
So the problems that you talked about are more sort of IRI kind of problems.
What I was talking about is
bad.
really,
That's good to hear.
it's really a roughness. It's really the profiling, and that's what. But because we rely so heavily on that IRI and that roughness being our number one, that's what people care about. That's why it matters so much to us. I wish that we could, I wish we felt like that the distresses were adequate by themselves. But for the 25 years we've had a pavement management system, we've always weighted everything heavily on the ride score. Even though recommendations in the industry seem to be going the other way to say, well, just do it PCI based and do it with distresses. We didn't find that correlated very well with what the citizens were calling about. Citizens would be fine driving up and down a road that has quite a few cracks in it if it was smooth. But as soon as that street was doing this, even if it didn't have a single crack in it or pothole or anything, we'd hear about it immediately. So it just seemed like even in the city, at low speeds, people were still very sensitive to roughness, ride score.
Right. Yeah, I was just mainly interested to know how accurate the cracking automatic.
We felt like
cracking
we've gotten
was.
pretty
Did-
consistent
Which
data.
vendor are you using?
We're using DTS right now, but we have used Fugro and
Pathways?
Dynatest. We've used Dynatest as well. So,
Are they using that LCMS, Pavmetrics LCMS system?
I don't know. Vina, do you know? I don't know specifically. Sorry.
Oh, very cool. Thank you very much.
Okay.
Any other question? Well, if you come up with anything they're going over, they'll be around this week.
Yep, we'll be here. Thank you.